Have you ever got a horrible mosquito bite whilst on holiday and wondered, why me again? And was your travel buddy someone who never got one? It could very well be to do with their fashion sense. Anushka Handa spoke to Jeff Riffle to find out more.
We've been working on looking at the sensory biology of mosquitoes and what they specifically find attractive to us, what types of smells and visual cues they might use to locate humans. They are exquisitely sensitive to carbon dioxide, temperature, sweat. All of these factors influence their attraction to individuals. One aspect that is relatively understudied is their visual sense and their ability to detect humans and how they actually use that visual information to find hosts.
What happens when they smell CO2?
Once they smell the carbon dioxide, they become visually sensitized. Their visual system allows them to actually begin immediately to look for you.
What do they actually look for?
They have really strong preferences to these colors that are reflected from our skin. These are colors in the orange to red band of the visual spectrum. Carbon dioxide seems to activate really strong attraction to these colors.
If we emitted blue wavelengths, would that change how much they'd be attracted to us?
No matter what your skin tone, we're not emitting a lot of blue or green. We're just emitting a lot of orange and red. And so it's this signature for the mosquitoes and going, oh, this is an appropriate host, especially for these mosquitoes that are specialized for us. If we started playing with these color bands on our skin, then we can actually start altering their behavior.
How did your experiment do that?
We actually took aspects of the field and simulated them in the lab using a wind tunnel and released the mosquitoes within this tunnel. And we would video their behaviors. And within the tunnel, we could simulate both the wind, the odor, the visual environment. We could take all these things that are occurring in nature, but recreate this in the laboratory, allowing us to test many different aspects of their sensory and visual environment. What we found is that they would go to red objects, orange objects, but they really avoided white objects, blue and green. So it was a way for us to run these experiments rapidly.
What colour clothing should you actually wear to stop them from biting you?
If you wear blue, purple, white especially, they are not attracted to those colors at all.
The red is quite close to the infrared. Is any of this spilling over into the infrared?
We actually tested whether or not they could see in the IR. So we use these optical filters. And when we place this red object on the floor of the tunnel, if we put an IR filter over that object, they could still see the red band and they were highly attracted to it. They don't see into the IR. Having said that, they have exquisite temperature sensors on their antennae that they can detect radiant heat. And so they are using that to figure out a good place to land on your skin and to bite you.
These mosquitoes are specific to those that bite humans. That can cause a series of different illnesses, whether that's malaria, yellow fever. Do you think you could genetically modify or genetically engineer these mosquitoes to stop them seeing these wavelengths and therefore stop biting us? And how would that change our ecosystem?
That's a great question. We had these genetically modified mosquitoes where their photoreceptors for these long wavelengths were knocked out. These genetically modified mosquitoes were blind to us. Their flight behaviors were normal, but their visual attraction to us was eliminated. We also used genetically modified mosquitoes that could not detect carbon dioxide. And the same thing happened. If they can't smell the carbon dioxide, they were not visually attracted to us. And preventing the mosquitoes from seeing or smelling us are very highly attractive as potential ways to control these mosquitoes that are out there in the environment transmitting these diseases like Zika or malaria. But there has to be a lot more work. We don't know exactly if we release these genetically modified mosquitoes, how they might impact the environment. What we can say is that from these laboratory experiments is that these potential ways to eliminate the mosquito's attraction to humans is a way forward.
Reds and oranges pull in mosquitoes, so Donald Trump had better be careful. That was Anushka Handa speaking with Jeff Riffle from the University of Washington. The paper was published last week in Nature Communications.